Now, let's address the part of this LOS that asks us to compute the future value and present value of ordinary annuities and annuities due. An annuity is a stream of equal cash flows that occur at equal intervals over a given period of time. For instance, receiving $1,000 per year at the end of each of the next 8 years is an annuity. There are two types of annuities: ordinary annuities and annuities due. With an ordinary annuity, the cash flows occur at the end of each of the compounding periods. Ordinary annuities are the most common type of annuity and have widespread applications in the investment field. Keeping in mind that an annuity is a periodic cash flow that occurs at equal intervals, we can compute the future value or present value of an annuity by simply computing the present value and future value of each of the individual annuity cash flows. This approach to computing present value and future values for annuities could involve considerable computational time, particularly when the term of the annuity is relatively long. Please recall that when we solved for the present value for future value for a single sum, we knew either the present value or future value, we knew n, the number of compounding periods, and we knew the interest rate per compounding period. With the three known variables, we could solve for the unknown variable. When solving for the present value or future value of an annuity-type problem, we will know the number of compounding periods n, the interest rate per compounding period, the amount of the annuity payment, which is designated as PMT on your calculator, and we will know either the present value or future value. So we are working with 5 variables, or 5 keys on our calculator, where 4 of these variables are known, and we are solving for the 5th, which, with present value and future value applications, the 5th unknown variable is either the PV or the FV. Let's look at an example. Assume that we want to determine the future value of an ordinary annuity that pays $150 per year at the end of each of the next 15 years, given that the investment is expected to earn a 7% rate of return. To solve this problem using our calculators, we enter 15 for n, we enter 7 as the interest rate per compounding period, we enter negative $150 as our annuity payment using the PMT key on our calculator, and we compute the future value, which results in $3,769.35. Let's look at an example where we want to determine the present value of an ordinary annuity. Suppose we want to determine the present value of an annuity that pays $200 per year at the end of each of the next 13 years, given a 6% discount rate. This is an ordinary annuity because the problem states that the payments occur at the end of each of the next 13 years. So using our calculator, we enter 13 for n, we enter 6 as the interest rate per compounding period, which is 1 year in this case. We enter our annuity payment of $200 as a negative number using the PMT key on our calculator. We then compute the present value, which results in $1,770.54. Let's look at a problem that combines the concepts for the present value of an ordinary annuity with the concepts of the present value of a single sum. Let's assume that we want to determine the present value of 4 $100 end-of-year payments if the first payment is to be received 3 years from today. Let's assume that the appropriate discount rate is 9%. The best way to approach a problem like this is with a timeline. On this timeline you have 6 periods, and the numbers on the timeline appear as 0 through 6. Since the first payment occurs at the end of period 3, we want to place $100 below the numbers 3, 4, 5, and 6 to designate payments made at the ends of periods 3, 4, 5, and 6. The first thing we want to do with this problem is to determine the value of our annuity at the end of period 2. To do this, we enter 4 as the number of annuity payments, 9 as the interest rate, 100 as the payment amount, and compute the present value. So the present value at the end of period 2 is $323.97. We are working with a simple single sum of $323.97, which is the value at the end of period 2. To compute the present value of this single sum, we enter 2 as the number of compounding periods. Again, I is our interest rate per compounding period. Our future value is now $323.97. In order for a resulting present value to be a positive number, you must enter our future value as a negative number. In this case, negative $323.97. We can compute the present value using the CPT and PV keys on our calculator, which results in a present value of $272.68. Occasionally, it is necessary to find the future value of an annuity due, where the annuity payments occur at the beginning of each compounding period. We can handle annuity due problems with our calculators, but first we must set the calculator to beginning of period, or the BGN mode. To switch between the beginning mode and the end mode that we use for ordinary annuities on the TI BA2 Plus, press Second, Begin, Second, Set. When this is done, BGN will appear in the upper right corner of the display window. If the display indicates the desired mode, press Second, Quit. Normally you will want your calculator to be in the ordinary annuity mode or the end mode. So remember to switch out of the begin mode after working annuity due problems. Notice that nothing appears in the upper right corner of the display window when the TI BA2 Plus is set to the end mode. It should be mentioned here that while annuity due payments are made or received at the beginning of the period, the future value of an annuity due is calculated as of the end of the last period. As an alternative to using the beginning mode to calculate the future value of annuity due, you can simply calculate the future value as though the annuity cash flows were that of an ordinary annuity, and multiplying the resulting future value by 1 plus the interest rate per compounding period. Let's consider an example. Suppose we want to determine the future value of an annuity that pays $100 per year at the beginning of each of the next 3 years, starting today, if the cash flows can be invested at an annual rate of 10%. In this case, we want to compute the future value at the end of the last year in the life of the annuity, or at the end of year 3, even though the final payment occurs at the beginning of year 3, corresponding to the end of year 2. To solve this problem, we set our calculators to the begin mode by pressing Second, Begin, Second, Set, and Second, Quit. Then we input n equals 3, the interest rate per compounding period equal to 10, payment equal to negative 100, and we compute the future value of $364.10. We could have also calculated the future value of the annuity due in this example by treating the cash flows as an ordinary annuity and simply multiplying the resulting future value by 1 plus the interest rate per compounding period. To do this, we would have left our calculators in the end mode and entered n equal to 3, I over y equal to 10, payment equal to negative 100, and compute the future value of $331. Now we multiply 331 times 1.1 and get the value $364.10, which is the same value that we obtained when we used our calculators in the beginning mode to calculate the future value of an annuity due. While less common than those for ordinary annuities, some problems may require you to find the present value of an annuity due. Using a financial calculator, this really shouldn't be much of a problem. With an annuity due, there is one less discounting period, since the first cash flow occurs at t equals 0, and thus is already its present value. This implies that, all else equal, the present value of an annuity due will be greater than the present value of an ordinary annuity. To compute the present value of an annuity due, we can switch our calculators to the beginning mode, just as we did when calculating the future value of an annuity due, Or we can calculate the present value of the annuity cash flows as though they were ordinary annuities and multiply the result by 1 plus the interest rate per compounding period. The advantage of this second method is that we leave our calculators in the end mode and we avoid running the risk of forgetting to switch our calculators back to the end mode when the annuity due problem is completed. Let's look at an example. Assume that we have an annual discount rate of 10% and that we want to compute the present value of a 3-year annuity that makes $100 payments at the beginning of each of the next 3 years starting today. Since the payments in this problem occur at the beginning of each year, we know that we are dealing with an annuity due. So first let's calculate the answer to this problem using the calculator's BGN or begin mode. Set your calculator to the begin mode as we did earlier by pressing second, begin, second, set, second, quit, and then enter the relevant data. In this problem, n is equal to 3. The interest rate per compounding period, or I over y, is equal to 10. Payment is equal to negative 100, and we compute the present value of the ordinary annuity to be $273.55. We could have solved this problem by leaving our calculators in the end mode and computed the present value of the annuity as though it were an ordinary annuity, and then multiplied this value by 1 plus the interest rate per compounding period. With this approach, we would have entered n equals 3, the interest rate equals 10, payment equals negative 100, and computed the present value of an ordinary annuity, obtaining a result of 248.69. Then we would have simply multiplied the 248.69 by 1.10 to obtain the result for the annuity due of 273.55, which is the same value that we obtained when we calculated the present value of the annuity due using the beginning function on our financial calculator.